So I keep hearing about how it's going to be a terrible time to be a researcher in the US, just from like Reddit and random news article headlines and some news articles that I've read. Everything is like very catastrophist about the future of science research in the United States based on just what has been happening over the past, 6 months in the US regarding politics and budgeting and things and whatnot. And so I decided that I would spend a good chunk of time reading through the fiscal year 2026 NSF presidential budgetary request to Congress. So this is going to be a long one, right? First one back, great idea to bite off more than I can chew. And so it'll be chaptered out. All of the resources that I have used for this video are also linked in the description below. The thing that I am talking about in this video is a document that is directed at Congress. Its audience is the United States Congress, so a lot of the things in the document are not like scientifically rigorous or research concrete. They're very much like high level, hand wavy, not very not very scientifically rigorous statements about things, which is fine. Like, I understand that. I also understand that this is not my area of expertise. So United States budgetary policy and just the financial history of the United States is not my expertise. I just got my doctorate in mathematics, right? And I studied dynamical systems, right? So this is kind of out of my wheelhouse. But I feel like it was important for me to read through as someone who is pursuing the research side of things, because like part of doing the research side of things is applying to some of these grants and applying to some of these fellowships and trying to get the money from the NSF in order to fund my research, right? And do all of those things. And I'm just a fledgling little dude out there figuring it out because I have no idea what I'm doing. And that's the secret to adulthood, is that no one knows what they're doing and we're all just sort of winging it. Some people are very type A about winging it. Some people are very nonchalant about winging it, but we're all just winging it. So we should probably start out with what the NSF is. Like most of the resources that I'm going to use in this video, a lot of the information that I'm pulling from is directly from the United States government. So I'm going to be pulling from the NSF and the Office of Management and Budget, and whitehouse.gov, and just like what the government says that they're doing. And without editorializing too much, I feel like it will sort of speak for itself. So on the NSF's About page, they say that the United States National Science Foundation is an independent federal agency that supports science and engineering in all 50 states and U.S. territories. The NSF was established in 1950 by Congress to do three things. The first was to promote the progress of science. The second is to advance the national health, prosperity, and welfare. And the third is to secure the national defense. They go on to say that we fulfill our mission by making grants. Our investments account for about 25% of federal support to America's colleges and universities for basic research driven by curiosity and discovery. We also support solutions-oriented research with the potential to produce advancements for the American people. And so historically, the NSF has been able to accomplish, whatever that means, this goal by having a relatively low percentage of the overall United States budget. Percentages calculated by allocation to other federal agencies across the federal government in the United States. So, where is this at? And the reason we know this is because the Office of Management and Budget keeps a historical spreadsheet of which you can go find on their website, which goes through and there's a section in it that gives you the allocations to different federal agencies percentage wise. So it goes back to 1962. So it doesn't give you all of the data, but we can see from just looking at this particular piece of the spreadsheet that The highest percentage-wise allocation of funds by the federal government to the NSF was between 1964 and 1969. Yeah, 1969. 0.3% of the US budget is the highest amount, percentage-wise, that the US has allocated to the NSF. And then for the 5 most recent years for which data is populated in the spreadsheet, which is from 2020 to 2024, the NSF was operating on 0.1% of the overall national budget percentaged by allocation to other federal agencies. But yeah, so historically, the NSF is like a drop in the bucket in comparison to the rest of the federal budget. Which, if you're thinking about current events and you're thinking about like, what would I do if I was trying to cut costs across a portfolio of spending that I've been doing, I probably wouldn't start with like the leanest part of the budget, right? If you're looking at the leanest part of, or one of the leanest parts of your budget, you're not going to find a lot of relief from cutting those things. So just keep that in mind as I go through the rest of this video. So we should also probably talk about where we are in the funding process for the NSF, right? So if you know anything at the surface level of how US budgetary policy works, is that there's a deadline for Congress to pass a budget, but a lot of times Congress doesn't hit that deadline, and so there are auxiliary bills and things that are passed in order to fund the government. And the budget is kind of a mess. It's a thing that both parties kind of use as this sword of Damocles, and government funding in general is used as this sword of Damocles to get certain things done, and to create this tension in the government. And we've had government shutdowns in the past in the US and all of these things. But anyway, there is an official process that's supposed to happen. And so for these agencies, what happens is that it's good to remember that the budget is not just one bill. It's a collection of bills that are passed in order to allocate funds to the federal government. And so there's this nice little step-by-step thing that the United States government puts online on its federal budget process page. And so how this works, how this is supposed to work, is that federal agents create a budget, which is their wish list for what they would want funding-wise for that fiscal year. The OMB refers the agency's request and develops a budget proposal for the president, and then the president submits the budget proposal to Congress early the following year. This is where we are right now with NSF funding. So the president's fiscal year 2026 budgetary request to Congress for the NSF was released on May 2nd, 2025. So the request was for a total of $3.9 billion for the U.S. National Science Foundation, and it reflects a strategic alignment of resources in a constrained physical environment in which NSF prioritizes investments that can have the greatest national impact, whatever that means. Right, and so it's important to remember that this budgetary process that I'm talking about right now is distinct from the big, beautiful bill that just passed and was signed into law on July 4th, which as of recording was a little under a week ago. Right, so this is a separate, this is not a budget reconciliation process, which is what the BBB was. This is a standard budgetary process for the upcoming fiscal year. So this year's budgetary request to Congress was a total of 222 pages long. However, a lot of the points of interest that I will talk through in this video are kind of scattered throughout it. So if you're looking at the table of contents of this document, at first we're going to talk through some of the summary tables, which give you an idea of how funding is allocated and what's going to be changing from previous years to this upcoming fiscal year. And then we'll move on to NSF-wide investments. So these are things that all of the directorates are sort of focusing on, and how funding will be allocated to those projects. At least as I understand it. I might be phrasing that incorrectly, but the idea is that these NSF-wide investments are the goals that the president has for the NSF in the upcoming fiscal year and the funding plan in order to accomplish those goals. For research and related activities, this is where we get into the different NSF directorates and what their individual directorate funding levels will be. Again, this is just a request to Congress, right? So we'll talk about why this might be an accurate representation of what will come out of the budget for next year for the NSF. So I'm going to talk about a lot of different things, but since I am trying to do math research things, there are two directorates that are important to me and where I'll focus a lot of my attention. These are the Directorate for Mathematical and Physical Sciences, or the MPS, and the Directorate for STEM Education, which is also abbreviated EDU. And I've said directorates a lot, so I should probably tell you what a directorate is. Per the NSF, the U.S. National Science Foundation's directorates and offices support research and education across all fields of science and engineering. So the directorates are just basically your administrative arm of the NSF, and they're focused on different areas of support for managing these different grant and funding opportunities and things for different research projects, as I understand it. If you go on to the Directorate Office's webpage linked in the description below, you can also see an overview of each directorate and what they're responsible for. So MPS is responsible for astronomy, chemistry, theoretical and applied mathematics, physics, material research, and the OSI, which is the Office of Strategic Initiatives. And then STEM is primarily focused on education. So developing graduate students and undergraduate students in these areas, and hopefully those folks that will go on to hold jobs of technical importance with hopefully some level of competence in these areas, and or those that go on to work to preserve and further our ability to develop that workforce and our knowledge base in these areas. They also support research into how do we actually do this. So what are good testing schemes? How do we evaluate someone's competency in an area? So the first thing to highlight are a few quotes from the introductory paragraph for this budgetary report, or the introductory few pages of this report. So the first thing to read is just the first paragraph. So the National Science Foundation's fiscal year 2026 budget request of $3.903 billion reflects a strategic alignment of resources in a constrained fiscal environment. NSF is prioritizing investments that complement private sector R&D and offer strong potential to drive economic growth and strengthen U.S. technological leadership. This approach ensures public funding is directed toward areas where it can have the greatest national impact. Again, this is very similar to what I read before on the NSF's little blurb about the budgetary report at its link to it. So this is another instance of whatever that means. And if you are aware of where R&D in the technological world in the US is going, well, it's going to AI and quantum computing. So, and this is reflected in the introduction as well. So NSF's investments fuel groundbreaking discoveries, accelerate translational solutions, and expand participation in STEM fields. These efforts support a strong domestic workforce, bolster national security, and enhance U.S. global competitiveness in science and engineering. A new frontier of scientific discovery lies before us, defined by transformative technologies such as artificial intelligence, quantum computing, and advanced biotechnology. You should keep those three areas in mind as we go through the document. Also, special highlight to and expand participation in STEM fields. You should hold on to that little phrase too as we get to who is going to be participating in NSF activities year over year in the year-over-year comparison of those numbers. So breakthroughs in these fields have the potential to reshape the global balance of power, spark entirely new industries, and revolutionize the way we live and work. To secure our future, we must harness the full power of American innovation by empowering entrepreneurs, unleashing private sector creativity, and reinvigorating our research institutions. Again, a special highlight to reinvigorating our research institutions, as that will become clear as to why it should be highlighted later on. The overview continues by giving a high-level summary of each of the critical activities. So for AI, we have, including machine learning, autonomy, and related advances, $655.23 million of investments will bring together numerous fields of scientific inquiry, including computer and information science, cognitive science and psychology, economics and game theory, education research, engineering and control theory, ethics, linguistics, mathematics, and philosophy to advance the frontiers of trustworthy AI. I have no idea what that sentence means, or that last clause means, rather, just because if you understand anything about how AI works, then the idea of having a quote-unquote trustworthy AI is a little bit dubious. For quantum information science, or quantum computing stuff, including quantum computing and simulation, $231.15 million will advance fundamental understanding of uniquely quantum phenomena that can be harnessed for information processing, transmission, and measurement in ways that classical approaches do less efficiently or not at all. Current and future applications of quantum information science differ from prior applications of quantum mechanics by using distinct properties that do not have classical counterparts. The development of new applications for quantum information science will lay the groundwork for one of the major technological revolutions of the 21st century. We'll see how stuff is sort of allocated later, but like the big winners in this report are artificial intelligence and quantum information science. AI more than anything else in the report. Biotech, which was one of the other major things they call out in the introduction, falls under a continuing investment, but we'll also see that, like, even though it's a highlighted goal of the request, the funding request doesn't totally line up with it being a goal of the NSF this year. So the first table that we're going to look at is the overview of the fiscal year 2026 budgetary request. So this is made when we have full data of not the 2025 fiscal year outcomes, but when we have full data for the 2024 fiscal year outcomes. So all of the changes are going to be with respect to 2024 information. When we're looking at this table, the first thing that you'll notice is that, like, everything's getting a cut except for mission support services. When you're looking at the NSF by account, this is the NSF by directorate. So if you look at EDU and MPS, the ones that I'm concerned about for my own sake, EDU is, the request is a reduction by 75%. And if you look at MPS, the request is a reduction by a little over 2/3. They also total everything up together. So the total NSF discretionary funding decrease in request by a little over 56%, or so basically 57%, and total NSF budgetary resource allocation request of minus 55.3% over the 2024 total, which is that's a huge amount, right? That feels like a lot of change in the budget for the NSF, even if this wasn't a request. If you were to say, this is the budget for the NSF today, this would be like shattering. And to run a business where you have that much loss would be, anyway. So it's like, just number-wise, it seems concerning. For research and related activities, you'll also notice that the H-1B visa increase is also there. That's a little interesting, just based on, like, immigration things in the U.S. right now are kind of a mess. So if I was elsewhere and thinking and doing this process of trying to do the research route or academia, I would definitely not have the U.S. on the map, just based on recent developments with U.S. immigration policy, right? So it's interesting that we're increasing funding to that. The H-1B visa, it is a non-immigrant classification, so that sort of makes sense with the Trump administration's stance on immigration. The other cool thing about these reports is that they give historical data for how much funding is requested versus how much was appropriated each year for the past 20 years. Just to highlight where we're at, right? So 2025, we don't have complete information because we're like still in the 2025 fiscal year. Well, so this is in millions of dollars. So it's $3.90315 billion. A couple more significant figures there than we had in the beginning of the report. But you'll notice that this number is lower than every other request number made prior, which is weird, right? Like that seems so. I was interested in seeing how far back you could go to. So when was the last time that the NSF received around $3.90315 billion? And if you go back and you can go through all the historical summaries on the budget site for the NSF, they keep historical data. Some of it's like really hard to find. Some of it is like housed on independent websites, or like not independent websites. They're still under the NSF domain. It's just they're like when you click on a budget, it takes you to a separate web page instead of a document, and that web page is actually the budgetary request information and the budget information for that fiscal year. And so this document that we have this year is different than the format that this request was delivered in previous years. So just keep that in mind if you go dig through some of the sources in the description below. So if you go to that budget page, it appears that they only have summaries going back to fiscal year 1996. If you do some more digging, you can get further than that. So I was able to go back to, or 79. I was able to get back to 79, according to my notes. Yeah, I was able to get back to 79. But I'm sure you could probably go further if you spent longer on doing this research and had more knowledge of this area than I do. Without adjusting for inflation, the request this year is just a smidgen below the request number made for fiscal year 2000. Okay. And there the request totaled $3.95 billion. Every year since, we have requested at least $500 million more than the current requested amount. However, if you go ahead and use the U.S. Bureau of Labor Statistics calculator for inflation, if you adjust the request for inflation, the amount requested is just below the 1984 budget estimate. So what they actually spent, budget-wise, estimated in 1984, of $1.326 billion. So it's just below. So the adjusted for inflation request for the 2026 budgetary request reflected upon 1984 would be $1.25541 billion. And the request number for 2026 adjusted for inflation is just above the 1983 realized budget. So what they actually spent on the NSF in 1983 of $1.104 billion. The request amount for 2026 adjusted to inflation for reflected on 1983 would be $1.20442 billion. The other question that's worth posing here when we're looking at summary data for the NSF and how budget allocation has occurred and what we've spent on the NSF is to look at, okay, well, there's the number that's requested, and how well does that reflect the amount that we actually fund the NSF on average? This isn't a number in the report, so I had to make the spreadsheet myself by just taking the numbers from the 2026 request and putting them into just Google Sheets and doing some light Excel work. And you'll see that most of the time, the percentage discrepancy between the request and the actual appropriation initially is below the budgetary request. So it's usually around like negative 2.64% below the actual requested amount. And then if you were instead to adjust the percent discrepancy for adjusted appropriation amounts, which this happened for the NSF only 2 times out of the past 20 years. So once in 2009 due to the R&RA, which is the American Recovery and Reinvestment Act, also known as Obama's stimulus package, meant to alleviate economic stressors of the Great Recession, and the Disaster Relief Supplementary Appropriations Act of 2023, which was part of the Consolidated Appropriations Act passed as an omnibus spending bill that rounded out government funding for fiscal year 2023. Like those 2 times, those are the 2 times in the past 20 years where the initial allocated amount for the NSF had been adjusted later on in that fiscal year. So if you do that, then the average percent discrepancy between a request and how much we actually fund the NSF is very close to 0%. So on average, what is requested is what is given to the NSF in total. That doesn't mean that it's appropriated the same way that is requested. It just means that the total amount that is requested is usually around what the NSF gets to use that particular fiscal year. And if you look at the past 4 years for which we have data, so for the projection for 2025, not the past 4 years. So if the projection for 2025, and then the past 3 years before that for which we have data, you'll see that the NSF funding amount is actually substantially less than the requested amount. Feels a little weird, but if you're trusting the historical data and you are assuming that the historical data tells you something about what's going to happen next, then the request amount in total should be about what we allot to the NSF, which is kind of concerning. Like so the data tells you that projection wise you're going back to 83 or 84 in terms of funding amount for the NSF, which is what, over 40 years ago? Yeah, 2026, so 40 years ago. Yeah, so like over 40 years prior. Wild. But that's just like the overview of the request, right? So the request is like a flashback to 1983 and 1984, adjusted for inflation, or 2000 if you don't want to adjust for inflation. And we may or may not get the allocation the way that it's set in this request, but like the total amount is about what is allocated to the NSF on average. So even though I've been caveating a lot of things with like, the requested amount and where it's allocated may not be exactly how it's allocated by Congress, but on average, we expect that the requested amount is approximately what will be funded to the NSF based on historical data, all of these things. It's important to remember that Trump basically has Congress, right? Like a lot of things, almost everything that he's wanted to do, Congress has passed over the past 6 months, of the very few things that he's decided to go through Congress for, right? The big one is the BBB that just passed and was signed on Independence Day, right? So even though I keep caveating like, the allocations may be changed based on what Congress wants to do, it's reasonable to assume that the request and Congress's interests will align for the most part. There hasn't been like a huge fracturing of just like political momentum with the Republican Party, as far as I'm aware, over the past like few months, right? Like, I mean, there have been little cracks here and there, but there hasn't been like anything massive that has affected policy in such a way that it hasn't still gone in the direction Trump would like it to go. So even though I keep caveating things, like I feel like this might be a good estimate of what we'll actually get allocation-wise, which is why I'm going to talk about the research and related activities table, which is where the request breaks down things per directorate. So these numbers are the same thing from the overview for directorates, but just to highlight things again, right? The only directorate that's getting a increase is mission support services, which is, again, it just feels a little weird. It feels a little backwards. Like, if you want things to be more efficient in research, wouldn't you want to like be able to have more research projects going while having less administrative overhead? I also may be totally misunderstanding what mission support services is. In my brain, it's administrative overhead for the agency overall. But that might be wrong. In this version of the table, I've gone ahead and highlighted all of the math and math adjacent things. So computer science, engineering, math and physical sciences, and STEM. There are reductions of at least 65% in the request versus the funding amount for 2024's fiscal year in each of these areas. And we'll dig into this a little bit more a little later, but staying at the wide view level of the request, we also see that in the NSF projected funding profile, they are both expecting fewer proposals and grant applications and expecting to fund fewer of these proposals and grant applications at a fraction of the rate that they did in fiscal year 2024. And this holds true for both competitive and research grants. Before we get into those numbers, I just wanted to give a definition of what a competitive and a research grant awards are as well. So for competitive awards, the statistics of competitive awards, they're using a definition that competitive awards encompass the universe of NSF new activity each year. Examples include research grants, cooperative agreements, equipment grants, fellowships, and conferences. All right, so these are new things for the NSF. And then the definition that they're using for the statistics regarding research grants is that research grants are a subset of competitive awards. Right, so it's just a smaller section of competitive awards. So a smaller set of new activities for the NSF that are limited to research projects and exclude other categories of awards such as those for cooperative agreements, equipment grants, fellowships, and conferences. So if you want to understand how much money is requested to go to or is projected to go to research grants or just research itself for the following fiscal year, you need to understand the research grant projection. So the highlighted yellow stuff that I've included above the table just basically says that like all of these numbers are projections based on the expected proposal pool. For fiscal year 2026, they're expecting less proposals to be made, less awards to be given out, and the funding rate of those awards to be 7%, right? And then if you subset that to just research grant awards, right, because research grants are a special class of competitive award, then they expect there to be even fewer research grant proposals, even fewer research grant awards. However, the median annualized award size is going to increase, but they're also decreasing the average number of years for a grant. But those changes are very small. So the big things about this table is that the funding rate is going from about a quarter of grants and proposals getting funded to about a nickel of grants and proposals getting funded, right? You're going from 26 to 7% and 24 to 6%. So like that's like the research stuff, and we're gonna come back to like grants for particular things, like grants for postdocs and grants for graduate students and undergrads and things like that. We'll get to that in a moment. Before talking about like grants and fellowships and things like that, in particular for like particular things like postdoctoral and graduate student and undergraduate student stuff, I also wanted to talk about participation rates that are projected for the NSF for fiscal year 2026. There are 5 categories that are especially concerning for me as someone who's interested in math and research and mathematics, and also being that I'm about to start a postdoc. And those are a participation of postdocs, graduate students, undergraduate students, pre-K through 12 teachers, and pre-K through 12 students. In particular, these are the developmental groups. These are how you get people interested in these things to pursue them, to retain our knowledge base of this information. The NSF estimates in fiscal year 2026 about 90,000 people will be directly involved in NSF programs and activities, receiving salaries, stipends, participant support, and other types of direct involvement. So that seems like a lot, a large number. But if you compare it to fiscal year 2024, the total number of people that participated or were involved in NSF activities by, again, either being directly involved, receiving salaries, stipends, participant support, and other types of direct involvement, that number was 330,000 in fiscal year 2024. So that's a reduction by quite a bit. Right. So like senior researchers and other professionals, those are concerning for different reasons. But for what I'll focus on for this little section of the video is that we're seeing about like less than a fifth of the postdoctoral associate participation level, about a little over a third of the graduate student participation level. And then you have severe reductions in undergraduate students, pre-K through 12 teachers, pre-K through 12 students as well. The biggest decrease being in pre-K through 12 students, which is where you foster an appreciation for the sciences, and so that those kids go on to do degrees in these areas and take interest in these types of things. Another way of saying this table out loud is that instead of saying that there are 90,000 people that will be participating in NSF activities, it's to say that 240,000-ish people are not going to be receiving salaries, stipends, participant support, and other types of direct involvement that would fall under a flat continuation of a fiscal year 2024 plan. The request report also breaks down what they mean by each of these groups, which is important to understand. So like, what kinds of postdocs do they want to talk about? What kinds of grad students do they want to be involved in, undergrads and teachers and students? So postdoctoral associates are individuals who have received a PhD, a medical doctorate, or a doctorate of science or equivalent and are not faculty members of the performing institution. These individuals are supported through funds included in research projects, centers, or facilities awards, as well as by postdoctoral fellowships, right? The big one here is postdoctoral fellowships, because a lot of times as a postdoc, the like quote unquote stereotypical route to go through is to apply for a lot of these NSF things to try to get funded for your research program or to supplement the research program of your postdoctoral mentor. We're going to hit the postdoctoral fellowships in just a minute. For graduate students, these include those that are compensated from NSF grant funds. NSF supports graduate students through NSF fellowships and training programs, as well as research assistantships and funds to assist senior researchers or postdoctoral associates in performing research through awards for research projects, centers, or facilities. NSF provides support for approximately a quarter of the U.S. science and engineering graduate students receiving federal funds and about 4% of the science engineering graduate students in the U.S. overall. And they cite an NCSES survey of graduate students and postdoctorates in science and engineering from 2023. Right, so to get that quarter and 4%, they're using a study from 2023. So to push that forward into fiscal year 2026 doesn't seem right in a projection mindset. And then undergrads, right, these include students. The main thing here is that these are the way undergraduate students participate in NSF activities is that they're assisting senior researchers or postdoctoral associates in performing research. And also, one of the big things for math is the research experience for undergrads. So a lot of people will do a research experience for undergrads as a mathematics or computer science undergrad. And through that research experience, they will figure out what type of thing that they would like to pursue in graduate school or in the route they would like to take in order to get a PhD, and like what area of mathematics or computer science that they would like to specialize in. I didn't do an REU myself, but I did have a REU-like opportunity with my undergraduate advisor at my undergraduate institution. And I've also helped mentor one of these types of experiences for undergraduates while I was in grad school. These types of things are really, really fun to do, but they're also like very important to like fostering the preservation of the knowledge base part of things in mathematics and computer science. So when you say that there are going to be fewer participants amongst the undergrads, this is also a little demoralizing because you're going to just have fewer people seeing what they would want to do technically with the math or science that they are studying at an undergraduate level, right? As someone who's now done a doctorate in mathematics, I can tell you for sure that like undergraduate, at least for math, undergraduate math, it feels very opaque as to where it technically applies in the world. Even when I was taking applied math classes, things would be thrown out as applications, but it wasn't clear to me how you would actually go about doing some of the things that the professor said you could do with the math. But like REUs are a great place, especially for applied projects where people can get hands-on and see how actually a lot of this technical machinery is used to do real-world things. But before I move on, I should mention teachers and students, right? So these are, for teachers in particular, this is for intensive professional development experiences in the sciences and mathematics. So in the same way that teachers are not taught how to teach reading, and for which, if you are not familiar with this, I would 100% recommend the podcast Sold a Story, which is about the history, well, the recent history of literacy education in the United States. Teachers are not always trained in how to teach math and sciences. So I've personally experienced this, right? So shout out to my third grade teacher for whom I had to correct their multiplication tables when they were teaching us multiplication, and who gave me a B in mathematics despite me getting perfect scores on all of my homework and tests in retaliation. It was a very, very weird time. It's fine. Like everything got fixed. I had a very intense parent-teacher conference where the principals were there, and it was a whole thing. But like the grade got figured out, and I didn't have to be in her class for fourth grade. Heck yeah. But the thing is that if you want your instructors to teach something, you don't want instructors to teach material like multiplication when they're going to fight you on 6 times 7 being 53, which is funny for two reasons. One, because 53 is an odd number, and two, because 53 is prime. You want your teachers to have an understanding of like how students actually learn the material and what are good pedagogical tools for actually communicating that information. Nor do you want someone who is an expert in these areas have no sense of how to communicate it at all. And so it's important to do these fostering programs, especially for math, because if we know anything, we've all seen the memes. Math is associated with primarily 3 things, and those are confusion, distress, and intractability. And if you go down the conspiratorial route, sometimes you get a little bit of secret knowledge flavor in there too, which is just, math has like one of the biggest problems of public perception of all of the STEM fields. But again, this goes hand in hand with participation in NSF activities for students, because you want people to have a positive outlook on the different fields of science, because you want those people to dedicate their lives to furthering those areas and making innovations for the wider community and for the world, or at least that's the hope, right? So, right, for example, Scratch, the free programming language, it's a visual programming language, and it's used by you like drag and drop these building blocks together that only fit with pieces that they work with. It's one of the most accessible and successful introductory tools to logic and computer programming, and it was created based on NSF funding. It resulted from an award of $1,999,435, and it has overwhelmingly accomplished its predicted goal of, quote, advancing the understanding of the effective and innovative design of new technologies to enhance learning in after-school centers and other informal education settings. And we know this because we have the actual NSF grant award. You can go online and find this grant award and see like what their abstract was and what their goal was and how much they were funded and all of this stuff. It's linked below. I'll put it up on screen here too. But you want things like that to exist because that's a huge return on investment. Not only are you developing a tool that can be used in education settings, you're giving people access to this thing to develop their own projects, and this goes in, and you're doing this at a young age. So like many things with the NSF, your return on investment monetarily is often several steps removed from the actual grant. And so it's not always clear to people why funding a particular thing gets you the large return on investment that it does. I need to speed round through some more tables to wrap this video up. And so lastly, I want to go through the NSF administration priorities and cross-cutting research topic summary tables, just because I don't really have enough time to go through the rest of the things that I wanted to talk about. But I got through like 2/3 of it. 2/3 of it. There's so much more to talk about. But the theme with all of these things is that if it's not quantum mechanics and it's not, more importantly, AI, then we're not requesting funding for it. So advanced manufacturing, education, and mathematics and physical science, no request. For advanced wireless communications, mathematical and physical science, down in request by 80%-ish. Artificial intelligence, the big winner. You have education remaining the same, math and physical science increasing by about 1/4. And then there's a huge increase in GEO programs, which is it's the largest percentage number in this entire document. It had to be highlighted. And then for biotech, remember that's one of the main goals of the funding for fiscal year 2026. Well, apparently not so much, because the only thing that's increasing there is for GEO programs and for SBE, education and math and physical science, down by about 3/4. Next, we have microelectronics and semiconductors. Education is actually up here by just a little bit, whole $2 million for that. But math and physical science is a no-go for no request there. Quantum information science, the only real change is for GEO programs. Everything else is a continuation of the 2024 fiscal year plan. So even though it's one of the main goals, no real additional funding is happening there except for a little tiny drop in the bucket of $1 million request-wise. National Nanotechnology Initiative, math and physical science and education, gone from the request. Networking and information technology, research and development, education, gone from the request. Math and physical science, down by a little over half in request. NSTC Crosscut, Clean Energy Technology, and NSTC Crosscut U.S. Global Change Research Program. These are the things that study stuff like renewable energy resources, how the climate is changing over time, how the world, like ecology and all of these things. Bloodbath, right? Like it's not a tree fell in the woods and no one heard it. Like there's U.S. Global Change Research Program is on its last limb request wise, but Clean Energy Technology has the lowest amount. It's like if you took your income and you cut it by 99.2% or by 96.7%, you would not have money to do things. If you want to look at what the U.S. Global Change and Research Program is. The program began as a presidential initiative in 1989 and was codified in Congress through the Global Change Research Act of 1990, which called for a comprehensive and integrated United States research program which will assist the nation and the world to understand, assist, predict, and respond to human-induced and natural process of global change. So it's just exactly what you think it is. It's the how is climate change doing, and we're just not requesting any funds to study that at all for the most part for fiscal year 2026. Okay, so the document covers like goals of funding, which are, again, these are not like research rigorous indicators of what actual research will happen in these areas, but they're more of like overarching. We're telling Congress what we want them to think about when they're funding these things. The big goals are quantum information sciences investment and artificial intelligence investment, more so artificial intelligence based on the numbers that we just saw on that table, than quantum information science. But one of the things that is kind of concerning is that, like, in some of those goals, like for advanced manufacturing, they mention one of the goals is the development of new materials. And if you look at MPS, which was the thing that funds material science, we just don't request any funding for MPS for fiscal year 2026, right? So I would recommend going through and reading those goals on your own time if you're interested in those sort of things. But the very, very last thing that I want to do is to talk about grants. So for grants and fellowships, right? So for fellowships for undergrads and graduate students, those are being reduced across the board. In particular, your NSF research traineeship, this is the thing that, trains you to be a researcher, right? It's supposed to. That's not being requested funds for. The Robert Noyce Scholarship, or the Noyce program, is also being heavily reduced. If you're not unfamiliar with the Robert Noyce Teacher Scholarship Program, it provides funding to institutions of higher education to provide scholarships, stipends, and programmatic support to recruit and prepare STEM majors and professionals to become K through 12 teachers. So it's the program that's trying to get people that know math and science to go and teach math and science to our children, right? So the program seeks to increase the number of K through 12 teachers with strong STEM content knowledge who teach in high need school districts. So this is a we want more teachers that teach math and science to know math and science thing, and that's being heavily reduced in request. Postdocs, if you're not in economics and you're not doing something that is engaging with the private sector, there is no request for funds for you. So for me in particular, feels kind of bad, man, as an incoming postdoc to a mathematics department, right? There are a lot of things here, or there are a few things here that are like things to think about. Mainly, there are mathematical sciences postdoctoral research fellowships and STEM education postdoctoral research fellowships that are, there's also the MPS Ascend. These sort of things are things that, anyway, so very demoralizing end to the video for me in particular as an incoming postdoc who is in math and is in mathematics. But so just to flesh out some of these things, entrepreneurial fellowships are NSF grants that are given to like fledgling companies to do new innovative things. And then SPRF, which I have pulled up all the way over here. So these are grants that are, so the SBE postdoctoral research fellowships. Sorry, So the SBE Postdoctoral Research Fellowships, or the SPRF, these are things where the research and training plan of each fellowship must address important scientific questions within the scope of the SBE Directorate. And the SBE Directorate is the Social, Behavioral, and Economic Sciences Directorate. So people that study the economy and how people act. I don't really know how to end this video. It was a lot of information. I know, hard transition there, but it's a lot of information. I started the video with this like curiosity of like, I hear that things are going to be bad for STEM researchers in the United States in the near future. And as someone trying to do that path of things currently in this day and age, it seemed relevant to me to read through this document and to try to digest what it's saying and some of the historical data to see if like what it's saying is potentially reflective of what will happen in the future. And by doing all that, I kind of feel bad about like what comes next. It's one of those things where it's like I don't plan on like abandoning my goals of doing the academic route and becoming a researcher in mathematics and doing all of these things. That's not something that I want to just like push off to the side and say I'm not going to do that. But this request is very demoralizing. And I can keep telling myself to the end of time that like, well, it's not official. It's not actually what the budget is and all of these things. But if you are a graduate student or you are a postdoc in a STEM field that is not related to quantum information science or AI, it looks like things are going to be kind of gross for the foreseeable future, or at least for the next couple of years. If Congress and the executive get out of sync at midterms, then things might be different. But yeah, it's just all sort of up in the air, and it's not fun to dwell on, which is what I'm going to have to do in order to edit this video. Anyway, yeah, that's it for this one. I know it's not strictly math, but it's math adjacent. I felt it was important. It was important for me to get myself to make it just so that I'm aware of what's going on. Yeah, I think that's going to be it. Things are linked below. But yeah, it seems like it's not a great time to be a mathematician. That is, as long as you're not doing quantum or artificial intelligence, you're having a bad time. Anyway, or might potentially have a bad time because clarifiers. Cool. I will see you in the next one.